Hi, everybody. In the next 15 minutes, you and I together will try to achieve three things. The first is we'll try to review some general tips and tricks about integrating your LLM into an app, even if this app or program is deterministic. The second is I'll try to make the case that when you do that, then for all intents and purposes, prompting is programming. Last but not least, if nothing else, I'll at least try to inspire you to use LLMs in a way that you may have not done before. As I was so graciously introduced, my name is Omri. I'm an Applied LLM Engineer at Semperis. And what that means is that I get to spend a good chunk of my time developing cool proof of concepts. And this is one of them. This is called the Parliament. Essentially, a group of LLMs joined together and moderated by another LLM. And they're trying to help you achieve some objective that you refine and define together. The title, if you need one, is a multi-agent RAG system. We will focus mostly on the multi-agent aspect of this. Before we get into the details of the system, I want to get to know who am I standing with here today. By show of hands, have you seen something like this before? Okay. For those who haven't raised their hands, now that you see it, do you understand what this is? Okay. To bring everybody to the same page, this is how you interact programmatically with an AI. At some point, you will have to define the model. So in this case, GPT-4o, and you have to give it the context of the conversation so far. In this case, I'm telling it who the assistant should be. You're a helpful assistant. The user said knock knock. The assistant asked very graciously who's there, and the user said let us. The conversation may continue. So what is the challenge we're trying to solve here? Take, for example, something that we as Semperis encountered and other organizations may have as well. You have a monorepo which stands and serves your organization as it is, but in order to expand it and maintain it, of course, you need to maybe restructure it into a bunch of microservices. The question is, do you do it all at once? You know, a one-off effort and that's it? Or do you do it gradually? There are advantages and disadvantages to each choice, but I think it mostly depends on the context, right? It depends on the company, it depends on the team that is about to do it. It depends on your history. Have you succeeded doing something like this in the past? The naive approach to this, because this is AI dev after all, you might say, okay, what's the problem? I'll just ask an LLM. Yeah, I'll go to the Grok, to Gemini, to whatever, and ask it, should I do this or that? For context, no problem, I'll just give it my company context, if you can. If you can. Not always you can. To avoid bias, because you asked Claude or you asked Gemini, and because of the way you specifically introduced this problem, you might ask it several times and then synthesize to avoid bias. At which point you might realize this is pretty complicated to do. And for a good reason. The leading industry actors try to do it, and it's called deep research. This exists. This ability existed, I think, since early 2023. They realized this is something they need to do, and they've done it, and it's really not easy for enterprises. First, it's expensive. If you buy that capability from those providers, you will have to pay a lot. And if you don't, then using the free version, do you really want to share all of your organization's information with that provider? Can you even do it? Is it organized? So here's our goal. We want to answer any question in any domain of expertise using our own context, automatically of course, and we want to do it unbiasedly, with an unbiased system. Important to say, this is for internal use only, because if it was for external use, the whole validation process would have looked differently than what I'm about to show. The inspiration for this project came to me in June this year, seems like forever ago. And this was when Microsoft introduced this little paper over there at the left. It's called The Path to Medical Superintelligence. What they showed is that if you want to diagnose a patient, given their symptoms, and you ask a human general practitioner, under certain circumstances, you only get 20% success. This doesn't mean that your doctors back home are not good. It means that under these circumstances and these specific illnesses, Human GPs were only able to do it 20% of the time, and the tests they would ask the patients to go through would cost $3,000. Back then in June, if you ask state-of-the-art model, O3 GPT, to do the same, they would achieve much higher accuracy, but it would be way more expensive. Microsoft showed something really cool. They showed that if you ask a team of LLMs to do it, you get almost the same accuracy and much cheaper. Of course, you can gain even 6% more of accuracy if you allow it to be in what we call high effort, takes longer, more resources, and the tests will be more expensive. So I'm pretty happy with that. If we can achieve something like this, that's great. Let's talk about the parliament. The parliament consists of 4 stages. The first one is to make sure that you don't give garbage to the system, you know, garbage in, garbage out. If you don't define your objective well, you won't get a good output. So the system would iteratively interact with the user, natural language, in order to refine the objective. Then once you have the objective refined, the parliament is created ad hoc for this purpose only, dynamically. For example, if you ask it something about medicine, you might not be surprised to know that the personas are a doctor and maybe a medical engineer. Then we go to the heart of the revelation or the discovery process. This is the discussion. The discussion has to answer multiple criteria. We need to avoid the corporate meeting. If you know what that is, great. If not, I'll expand later. We need to make sure that the parliament members confront each other using their own agendas, their own expertise, their own point of view, and they try to sort of tackle each other and find the weak points. We want to anonymize the responses. There is a single LLM standing at the center, orchestrating this whole party, and we want to make sure that that LLM doesn't know who said what, to avoid its biases as well. Eventually, I think a very strong technique is to have each of the personas reflect about the solutions they proposed and see maybe they changed their opinion from A to B, in which case this is probably very good evidence that solution B is really good if it managed to change someone's opinion. And last but not least, nothing is perfect. We want to allow the user to intervene whenever they want. So the user can stop the discussion at any point and say, member number 2, what you said completely doesn't make sense, so please revise. Or maybe you want to say, hey, you know what? I forgot to say something at the beginning, but I see it's important now, so you add context. At the end, I would say a standard summary stage. It summarizes it in text or in Markdown or in a beautiful HTML if you want to read it for some reason, other than feeding it to another LLM, which is my favorite solution. Another important thing to note before we dive deeper into the system is how to use an LLM as a flow director. Let's say we got this email from a customer. Our company manufactures guitars, and we get this email. It says, "Dear Mr. Han, where's the guitar I ordered? Greetings, Rob." And we want to know which department should answer Rob. Should it be the workshop or should it be the logistics department? Of course, there are classic, traditional, non-LLM related techniques to use. You could use other machine learning techniques like naive Bayes or decision tree. But if you do want to delegate this task to an LLM, this is how I would do it. I would tell it 3 things. The first one is the input. This is the email I received. It starts and ends in these tags. And here's your task. Which department should reply to this email? Should it be the workshop or should it be the logistics? Maybe some additional context will help. And last but not least, I want to define the reply format. This will be in a JSON format. Use XML, use whatever you want. And in here I have 2 fields. One of them is the department. This is the answer I'm going to use to direct the flow. And for debugging, maybe I also want to see the reasoning, so I can debug and understand why something didn't happen when I expected it to. And now we're free to talk about the techniques. Each of the techniques I'll introduce, 3, maybe 4 if time allows. Each of them deserves their own 1-hour discussion, maybe a whole day. But that's what we have. If you find those interesting and you're also LLMs geek like me, come see me at Semperis booth or find me on LinkedIn later. So the techniques concern 2 aspects of managing LLMs in flow. One is the cognition, and the other one is the architecture of the software itself. The first technique is how to avoid the corporate meeting problem. And for those of you who don't know, the corporate meeting problem talks about a situation where a bunch of members or colleagues gather together to discuss a topic and propose their solutions. Bless you. And the first person to talk sort of hijacks the conversation. And everything now is talked through that agenda. We want to avoid that. The solution is pretty simple, actually. We just let each LLM propose their own approach, their own solution, without seeing what the others have said as well. This sort of enhances the ability to avoid bias again. Second problem we want to avoid is how to dynamically flip the perspective. The conversation so far has gone like this. We had 4 messages. The user said, I'm the user. The moderator said, I'm the moderator. Members number 1 and 2 of the parliament said, I'm 1 and I'm 2. And at this point, the moderator wants to ask member number 1 something. Maybe it's just want to give it an order, say something. How will we do it? We need to format the messages in some way. Let's see how. We all remember that sending a message to an LLM always looks like this. It's always some abstraction of getting the response, defining the model, and giving it the list of messages so far. What message do I give it? What list of messages do I give it? A message, again, is nothing more than a dictionary with 2 fields. It's a role and a content. The role can be the system prompt, it can be the user, or something the assistant said, and the content is whatever string. So the first one would be the system prompt, right? Generated dynamically or before the discussion per persona. The rest of the messages either come from the user or the assistant. Nothing much you can do about that. So the distinction is between messages sent from the user. I'm the user, I'm the mod, I'm member number 2, and say something. And a message that was allegedly sent by the assistant itself or by the member you're addressing. That's member number 1. However, of course, we're still missing something, right? We still don't know, unless you know who the user is, you don't know who actually said that, especially if the sentence is something else. So let's just add a small prefix and we're done. Do that dynamically, and this is the approach I chose to implement. Technique number 3, how to validate output. If no other slide from this presentation, remember this one. I'll present 2 ways to validate the formatted output as a JSON and choose whatever. The first approach is the incremental retry. You ask the LLM first to produce the JSON. Remember the example with the guitars? You try to parse it and get the fields you need. And then you either succeed or you fail. If you succeed, great, you're done. But if you fail, you might want to retry. But don't just retry on a simple retry logic, you know, if attempt greater than 0, then retry. Tell it why it failed. This is a thinking assistant you have here. Use it. The other approach was suggested to me by Nadav Naveh, he's the CTO of Congreat, and he just says use the best of 2 worlds. Take DeepSeek, which is a cheap yet relatively strong model. It's not perfect. Definitely not as strong as Claude 4.5 of its varieties, but way cheaper. So use that to sort of structure and extract the data needed, and then ask a much cheaper, faster model to structure it in the format you want. Specifically the GPT family, if you have programmed with them in the past, you know they have a very good functionality of following the format you want. I have not tried this approach, amongst other things because it's slow. You ask for 2 calls per parsing. The first approach only asks for 1 with the chance of asking it more than once. I also say that we started in the last few days working on other approaches as well. We will let you know when they're out. Even though this one is interesting, I need to skip it in favor of time. But if you found any of these interesting and you think, like me, they're worth discussion which goes way into more details, please, please, please find me at the booth. I'll geek out with you until dawn. Or find me on LinkedIn and let's connect. Thank you.